In this movie, we're going to look at object diagrams or instance diagrams in UML and what you might use them for. Object diagrams are far less widely used than class diagrams, and while it would be reasonable to produce a set of class diagrams for all the classes in the system, object diagrams are likely to be used just for specific purposes. Typically, we use object diagrams to explore issues or to reason about aspects of the system, where it's useful to think about the actual objects rather than classes. In the movie on the distinction between objects and classes, I explained that we may model objects when we're looking at the real-world things in the problem domain, which we abstract into classes through analysis, and that we also use objects when we're thinking about what will happen in the live system, when instances of classes will be instantiated in memory. So the first purpose of object diagrams relates to that first case. We can use object diagrams to model the things in the problem domain before we've decided what classes we're going to create. They can also be helpful in thinking about the candidate associations between classes. We can also use object diagrams in conjunction with other types of diagrams, such as state machine diagrams or activity diagrams, where the dynamic behaviour of parts of the system is reflected in changes to the values of features of the objects in the static view of the system. Object diagrams are also useful in the design of interaction in the system, and for reasoning about the object instances that will exist at runtime and how they'll interact. That actual interaction will be modelled in sequence or communication diagrams, but the interaction will affect what objects are in memory and what values their attributes hold. When an analyst is exploring the problem domain, he or she will find instances of real-world objects that may be relevant to the system. These may be documents like orders or invoices, they may be people or the roles they play, or they may be physical objects like the devices and sensors in our home automation system. These real-world objects will have values associated with them and links with other objects. The analyst may choose to document these objects and the links between them in order to clarify aspects of the domain and to help analyse those objects into classes for the solution system. In the example shown here, which is from a system for a publisher, the fact that there is a link between a book and one of its authors as the lead author gets reflected in two associations between book and author in the class diagram. Incidentally, drawing the diagram then highlights the fact that we could have 0 authors but must have a lead author, which doesn't make sense. This could then lead to a discussion of the fact that some books have one or more editors rather than authors, and the lead must either be an author or an editor, and this would then result in a further change to the class diagram. State machine diagrams model the way in which the state of objects in a system changes in response to events. Activity diagrams show actions that may change the state of objects. In both cases, it may be helpful to produce one or more object diagrams to illustrate the changes that are taking place. In particular, the state that's modelled in a state machine diagram may actually map to a combination of values in multiple attributes, or indeed changes to links between objects, rather than just one attribute that holds a single state value. The state machine diagram here shows the way that the state of an open-closed device changes over time in response to events. It doesn't go straight from a closed state to an open state, but has to go through an intermediate opening state. While it's in the opening state, the state attribute holds the value open, but also the enabled attribute is set to true. Once it has opened, the state attribute continues to hold the value open, but the enabled attribute is set to false. Drawing the diagram can help to make these aspects of how the system behaves explicit. Drawing diagrams to model the objects that will exist in memory at runtime can help to design effective or efficient implementations. In this example, the timed events in a schedule are not sorted into any particular order. If every minute a real-time clock triggers a request to each schedule to check if there are any timed events that need to be activated, then having an unordered collection of events may not make it possible to design and implement the most efficient algorithm for the search. If the timed events are ordered by time, then it may be more efficient searching through them, and visualizing it like this may raise questions about how to optimize the search. For example, by holding a last event or next event attribute in schedule so that it doesn't even have to do the search each time, but goes straight to the next event to check it. So, object diagrams are a tool that can be used if it's useful to visualize and reason about either the real-world objects that are relevant to the domain, or to understand how objects may behave in the system that's being designed and implemented.